Okay, let's go over the question. So what do you do in the morning?
Went to school, teacher.
Oh, not went to school already.
Yeah, this week.
What did your teacher do?
Experiment. Supposed to become study, but then experiment. The
What is
whole week we were doing experiment.
this one is for the part of your course, is it?
Yeah, yeah, very important one. That can help you get 20 marks.
Okay. You are still very weak. Still very weak. Okay, these are all the things that you need to know. Okay, let's go over the answer. Okay, first one is wrong. Sinusoidal alternating current of peak value I naught pass through a heater or resistant R. What is the mean power? Right, mean power is just half of peak power. So we calculate the peak power first. Peak power is P naught, then I naught square times R, then half of it. Okay.
Go back again, sir.
Half of this one, that's all.
Oh, okay. Okay, understood.
Okay. That you must memorize. Number 2, you are all right. Which statement is incorrect about the alternating current? The root mean square of an alternating current is the value of the direct current that dissipate heat energy at the same rate in the resistor. That's correct. The root mean square value is this one is wrong. Right? It should be I naught over root 2. Peak power is twice the mean power. That's correct. Heating effect is given by I root mean square times R, where the current passing through the resistance R. Okay, so the wrong one is B, which you are right. Okay, this one is just testing you whether you know how to read the equation. Alternating current I in ampere varies with time t in second according to the equation that what is the mean power developed by the current in the resistive load of 10 ohm and frequency of AC supply. Okay, so find your peak power, peak power, I naught square times R. Peak is this one, 5. There's a peak current. R they are given 10 ohm, is 250. So mean power is half of peak power. So half of 250 is 125. Then compare with the standard equation, 2 pi f equals to 314. Okay, that 314 is 2 pi f. And calculate your f, 50 hertz. Okay. Can anything not clear?
No, I'm okay.
This one also wrong. The alternating current flows through a resistor. The variation with time of the current is shown. Which graph shows the variation of time of the power dissipated? Right? Power dissipated, remember, is I square R. So you square this one, it's still positive. You square this one, negative becomes positive. Square this one becomes positive. So it's 3 lump, 3 peak there. Right? No negative there. So answer is C. Can?
Can.
Okay. The main electricity supply has a root mean square of 240 volt and a peak of 340 volt. When connected to this supply, a heater dissipates energy at a rate of 1000 watt. The heater is then connected to a 340 volt DC supply and the resistance remains the same. At what rate does the heater now dissipate energy? Right? Remember, you are using the same resistor. So the resistor is constant. So the first thing is to determine the resistance first. Power dissipated is the mean power. Right? So that's the mean power is root mean square V square divided by R. So you are given heater is 1000. This is the mean power. Written down there. And the mean power is 240 volt square R. Find your R first. Okay, from there calculate your R. So calculate your R, then apply it to here. Right? Calculate again. V square over R. But instead of using V root mean square, you use this value. That's your DC voltage. Right? Resistance you have already calculated out, 57.6, and calculate out C. Okay, anything not clear?
Oh, I'm okay, sir.
Okay, then we go to number 6. There is a sinusoidal alternating current and resistor. What is the mean power dissipated in the resistor? Surprised that you can do one answer and then the others you cannot do. More or less the same thing. Right? Mean power is always half the maximum power. So it's donkey. Right? Maximum power, half the maximum power. Okay.
Okay.
This one also cannot do. An AC power supply with a constant root mean square voltage and variable frequency is connected in series with a pure capacitor. So we are looking at pure capacitor. Which of the following graph shows a variation of the root mean square current with frequency? Okay, we are looking at reactance. Then the answer is C. We're not looking at reactance. You're looking at current. Right? Reactance is given by this formula. So that is your reactant answer. Right? You want current. So it's voltage, root mean square voltage divided by your reactant. Right? Put this one there. So this one becomes on top. So this is the equation of a straight line. A. Okay. Yep. Memorize the reactance formula. Apply your formula for current. Ohm's law. This one, yeah, all right. Which of the following graphs shows the phase relationship between voltage and current when a sinusoidal current flows through a pure capacitor? Right? Capacitor, you must always remember the current lead the voltage. Right? Current lead the voltage. So in this case, if you look at the same point here, this point and that point there, this one tell you the voltage lead the current. Right? I leads V. So this one tell you your V leads I. So it cannot be A. This one is for resistor. Right? Look at the maximum point. I come first, the peak. So come second. So I leads V. The answer is C. Okay. So for inductor is A. For capacitor is B. Okay with that? Any comment? This one you know how to read. So yeah, all right. No need to use formula. You can use formula, but no point.
Rememorize.
Nothing to memorize, huh? Memorize this one here. Memorize this one. For capacitor, I leads V by 90 degrees. So you just look at a common point. Right? This one is the maximum is there. Or look at the 0 point. 0 point. This one is going down, this is going down. So look at the 0 point. This one, V come first. Then I. So V leads I. Right? This one, look at the peak value. I come first. Then V. Okay, so this I leads V. This one is more than 90 degrees already. Right? This one, you're all right. A pure resistor and a pure capacitor are connected in series with a sinusoidal voltage of root mean square V. The root mean square voltage across VR and across VC. Which of the following is the correct phasor diagram relating V? Okay, so always VR will be the horizontal one. VC is below. Right? Always remember that VC is below. The current flow in the same direction as the VR. Okay, make sure you know how to draw the phasor diagram. This one you are wrong. A pure capacitor or capacitance 2200 microfarad and pure resistor or resistance for ohm are connected in series with a sinusoidal voltage supply of frequency 50 Hz. What is the root mean square current in the circuit of root mean square voltage? Right. So to calculate, right, go to your DC. You are given voltage. You want to find current. So the main thing is to calculate the resistance, the total resistance of the circuit there. Right? So calculate your reactance for capacitor. Right? Memorize formula, put in your value, 2 pi, 50, that's your 50 Hertz. Right? That one, change to 10 to the power minus 3. Calculate out. Then calculate your Z. Right? Z is your total resistance or impedance. R square, XC square. Put in your value for 1.45. You get that. And finally, R root mean square, B root mean square over Z. Put in your value, 240 over that. So you get 56.5 ampere. Okay. If I'm too fast, let me know. Ken, anything cannot understand?
Can understand, sir.
Okay, then we go to 11 then. Right, 11, you have problem. A pure capacitor and a pure resistor are connected in series with a sinusoidal supply of maximum voltage 300 volt. If the maximum potential difference across the resistor is 180 volt, and the maximum potential difference across the capacitor, you want to find maximum potential difference of capacitor or maximum value. So you know how to draw the phasor diagram. I don't know why you don't know how to calculate. Right? Phasor diagram is just a vector diagram. Yeah, that's all. Right? So use vector to calculate Pythagoras theorem. You want to find VC is V square minus VR square. Put in your value. Right? There's a supply. There's across the resistor. Calculate out. Okay.
Okay.
12. Okay, 12, yeah, all right. That is the formula. V equals to V not cos omega t is applied across an inductor. Which of the following graph shows the variation of current with time? So the key to remember is which one lead which? I lead V or V lead I? For inductor. Yep.
Huh?
For V lead I or I lead V?
Oh, I lead D.
As long as you can remember that, I lead V. So this is the voltage. Voltage is this one, C. Voltage is B, C. So you want I leads V. I must come first. So this is V. Right? So I must come first. See, you look at the graph there, how do you count? How do you decide the answer? Yeah, how do you decide the answer? Yeah. Sorry, not I. V leads I, not I leads V. Sorry, my is V leads I. Okay, V leads I. So if this is your V graph, V leads I. You look at the peak there, right? There's the current. So answer is A. Whereas if it's capacitor, then the answer is C. Sorry, if it's capacitor, what am I doing? Oh, this one is just telling you this is for V, right? And then you want your V leads I. That's your V, the maximum come first, then this one come later. Okay, for capacitor, the answer is B. Right? Capacitor, if this is your voltage, I, right? This is your voltage. Your I leads V. So you look at this common point there. This is a common point. I leads V. Right? Should be able to recognize that. Alternative is to use this formula lah, and differentiate. Get your answer. Okay. That means you will get a sine graph. Right? This is a sine graph. Easier to remember this V leads I by pi radian rather than differentiate. Okay, next time you are tired, cancel the class. Don't come for class when you are too tired, cannot pay attention.
No, actually, you say the quiz. That's why I came here.
To me, it's okay. You want to cancel class, it's all right with me. Right?
Oh.
So tomorrow, are you okay or not?
Yeah, I'm okay, sir.
I don't want you to tired and come for class and can't concentrate.
Sir, you know what, sir? For this Saturday only, right, sir?
Yeah.
Can have 2 hours.
Why you want 2 hours for what? We have completed everything already.
No,
Unless
no,
you
the
got
past year only, what, sir?
We have finished already. Past year, you want to do it tomorrow or you want to do it on Saturday?
Saturday.
Oh, Saturday. Okay.
I'm talking about the past year.
Okay, past year, okay.
2
Past year.
hours.
I think it's better to have 1 hour. 2 hours is too stressful for you.
Yeah, too long.
Too long.
Okay lah, sir. Then tomorrow
1
lah.
hour, and then we will
1
see
hour.
can finish or not. Okay.
Sure. Okay. Sure.
Your inductor is connected to a sinusoidal alternating voltage with variable frequency, which graph currently shows a variation of XL with frequency of voltage. Right? Key is to remember that formula. Okay, so this is direct. This one they want you the current. Right? I think this question is a bit distracting lah. Right? Here they ask you which graph correctly shows a variation of XL with frequency, but here they give you current. Okay, so it's the fault of the examiner. Lo. So by right, they shouldn't penalize you. Lo. So if you look at, of course, they can argue lah. This is root mean square current. Lah. Okay, so XL, if it's XL, then this is the answer. Lo. Okay, but if you want current, then you have to replace the XL here. Right? It's just your voltage divided by resistance, that's all. In this case, it's reactant. Right? Put it there. Right? So this is hyperbola. So answer is donkey. Okay.
Okay.
Right? So this is poorly set. Alternating voltage supply to a 40 millihenry inductor is given by the equation. V is in volt, T is in second. The maximum current in the circuit, right? Inductor formula, find the reactance. Right? So your 2 pi f is here. 2 pi f is here, 200. This one, change it to Henry, 0.4. So it's 8. Right? 8 ohm. I naught over V naught XC. Put in your value. 5 is your peak value. Divide by XC is 8. So you get 0.63 ampere. Right? Answer C. This one, you're all right. You can do it. Good. This one also you can do it. In AC circuit, the current and voltage V across a certain component is shown. The component is, so sometimes it's very memory only. Right? This one tell you your V leads I. Right? Look at this point there. Going down, this is also going down. So V come first, so V leads I. Right? So answer is C, is an inductor. This one tend to be challenging for you. Sinusoidal alternating voltage of peak value V naught and frequency F is connected across an inductor or inductance L. What is the maximum current in the circuit? So same thing, find your X first, reactance first. Right? Reactance of the inductor, 2 pi F. And I naught is V naught over X. V naught is given. X is this one. Put in your value. So answer is C. Okay. 17. Sinusoidal alternating supply of frequency 50 Hz and peak 25 volt is applied to a pure capacitor. If the capacitance of the capacitor is 4.5 microfarad, what is the root mean square current of the circuit? Same as previously. Previously it was in pure inductor. So find the reactance first. That's the formula for reactance. Put in your value for F, 50. C, convert it to SI unit. Calculate it out. And current is voltage over resistance, or in this case is reactance. Put in your value. Right? You want root mean square current. So you are given peak voltage. So you have to 25 divided by root 2 first. And then there's your X. That's your X. Okay. Answer is C. You are still very weak in all these calculations. This one, you're all right. Graph of P and Q show the variation of reactance with frequency of the obtained current for two components. Right? So you should be able to recognize this is for capacitor, this is for inductor. Right? If not, remember the formula and then identify. B, 19, you're all right. Right? All these are taken from your book. I hope you didn't cheat. You know your work. In the circuit diagram, the voltage across R and C at the instant the current in each of the circuit is maximum. Okay, so you want to find the peak across in the circuit, the voltage of across R and C at the instant the current in each of the circuit is maximum. So the current is maximum. So this one is root mean square. You have to times root 2 to get maximum. Then come the tricky part. Okay, that one you can calculate. Okay, for capacitor, I leads V. When I is maximum, your voltage is 0. Okay. donkey. So this one, okay, you can do it. Resistor, this one can, because of got problem. Resistor, capacitor, and inductor are connected in series with an AC supply. The root mean square potential different across the resistor, capacitor, and inductor 20, 65, 30 respectively. The root mean square voltage of the supply. Right? If you want, you can draw. There's your VR, your phasor diagram. There's your VL. There's your VC. VC is larger. So VC minus VL is the black one here. Right? VC minus VL. Then use Pythagoras theorem. VR squared. Right? Remember the voltage is your vector. So we are using the Pythagoras theorem, this triangle. Right? VR square plus your VC minus VL square. Put in your value, calculate out. Okay. Any comment?
No, I'm good, sir.
Okay. This one also you cannot do it in study. Memory work. Right? I is for your Z. This is your XL. This is your resistor. This is your reactance for capacitor. Okay. Anything else you want to ask?
I'm okay, sir.
What do you want to do with the rest of the time? You still got some more time?
Tomorrow lah, sir.
Too tired already?
Yeah.
Okay lah, too tired. I won't stress. So Saturday, not tomorrow, Saturday.
I thought teacher say tomorrow.
You want tomorrow? You can go with it. You go to school and come back so tired. Up to you. You want
Saturday lah, sir. Yeah, Saturday can lah, sir. No problem. Saturday.
Tomorrow you got class.
Because last time I'm in the house, so no problem. Now I'm in the school already.
That's why you have to go to school. You come back so tired already. How to concentrate? That's why I say it's better on Saturday. Okay, so I see you on Saturday lah.
Okay, last class, right, sir?
Last class, and then if you need to ask one or two questions, you can text me. We can start a new Zoom, no problem. I can still help you. Unless you want to exceed half an hour, then there's a different case.
Okay, sure, teacher. Thank you.
Okay. Have a good rest.
Okay.
Keep on.
Have a good day, sir. Thank you.
Keep on working. Then you'll be all right.
Have a good day, sir. Thank you.
Okay, bye-bye.
Bye.